This tutorial shows how to draw and manipulate anchor curves, how the curves create a surface, and how to make a model using the surface. The software has 4 different modes, which you can change by clicking these or by using buttons 1, 2, and 3, and 4. The first mode to the left is rotation mode, and by clicking the left button, holding down the left mouse button, you can rotate the model. By holding down the right one, you can zoom by moving up and down. Moving left and right will do nothing. When you hold down the left button, you also see a red small point in the middle here. That is the center of rotation. The center of rotation can be moved by holding down both left and right mouse button, and then by moving the mouse. Now the center of rotation is here. Center of rotation can be reset by going into Look and Reset Center of Rotation. Also, if you want to view the model from map view from above, where north is upwards, you go to Look and say go look down. Now north, south, west, and east. To draw an anchor curve, you press this button here. You can draw it either by holding down the button and moving the mouse. You see lots of small points. And then when you release it, the points are subsampled, so you have fewer points, and then you see a surface has been created. By pressing the delete button, you delete the curve you just made. You can also draw a curve by clicking exactly where you want the points to be. To end the curve, you can either double click or go to the Anchor Curves menu and select End Curve, or press the button E as it says in parentheses. We have called these curves for anchor curves, since they act as anchors on the surface by forcing the surface to go through the points of the curve. The Anchor Curves menu has 2 parts. One part that are operations on the curves, End Curve, which I showed, delete the selected curve, delete all drawn curves, or load the curves that were used for the previous cut or fold operation. You have also operations on the points of the curve. To enable these operations, you need to select a point on the curve first. You select the point by left-clicking on it. Then it can also be moved. When the point is selected, you can choose to add point. That will add an extra point on each side of the selected point. Here you see the new points. Let's select this one. You can delete the point you selected, and you can cut the curve into 2 pieces by selecting the cut position and split. Now you have a curve here and a curve there, which you can manipulate independently or delete one or the other. The anchor curves can be moved around by opening Geological Modeling and Anchor Curves. Here you have for moving the selected curve up, down, northwards, southwards, west, and east. You can change the delta of movement with this button here, so that the steps are bigger or smaller. Notice that the selected curve has these green lines on each point. That is the normal of the points, and the curve, the surface, will intersect the point and respect the normal. We can rotate the normal by using these 2 buttons here. So let's see what happens with the surface. So here you see that the surface intersects the 3 points according to the normal, and this other surface has its normal like that, and the surface intersects according to that. So we can also rotate these normals, and then you see the result. The move delta is also applied for the rotation, and in this situation it means how many degrees. So it's 15 degrees for each time I press the button. All of these buttons also have a keyboard shortcut. So W, S, control up arrow, down, left, right. So that means that if you look at the model from above and you press control and the keyboard arrows, so up, down, left and right. Also, the buttons for moving higher, lower and rotating left and right have keyboard shortcuts. W, S, that's higher and lower, and rotating is A and D. For all these buttons, if you press Shift, the movement is 1/5 down if you don't press Shift. These other buttons explained, so rotate 180 rotates the normals to the opposite side, and then again it will go back. Upsample adds lots of points in between. In this case you see that we only have 3 points on the curve, and the surface only intersects these 3 points. So here we could upsample the curve. The upsample adds very many points, as you see here, so dense. But if you press downsample a few times you will get fewer points, and then you get this result here, and you see that the surface now goes through the curve more correctly. What load curves does is that when you perform a cut or fault, press cut, then it saves the curves that were used. So you can reload them by pressing load. And the reason why that is useful is that we have undo and redo. So if I do undo, Control Z, or just press this button, we go back to the previous state. And then I can press load curves, and you have them. And then you can make a change. And then press cut again. And then still, if this is not good, you can do undo. So let's use the keyboard shortcuts. Undo, Control Z. And as you see, load curves has a shortcut too. Control X. So you just press Control X and then you're back. So that means after doing a cut, you can do Control Z, Control X, and you can make a change quickly. Finally, we have this checkbox here, which makes the surface semi-transparent so you can look through it, which is useful when you're doing modeling. Also, it sticks out, whereas this one is cut by the bounding box. This also has a keyboard shortcut, which is 5 with Shift, which is %. The whole anchor surface can be toggled on and off using this one, which has shortcut 5. Save curves is called automatically when you press cut or fault, but you can press it yourself if you have a complex shape consisting of many curves that you want to save. So if you press save, you will see down here the path to that curve file, and this file will be overwritten whenever you do a cut or fault. So you should rename it, and then when you want to use it, rename it back, and then you can press load, or you can send it on email to others. There are 2 ways to create a planar surface. Let's delete this surface. The first way to do it is to make a curve that consists of a single point. So we click and we end the curve. Then the point will have a normal. This goes straight up, and therefore you have a surface that adheres to that normal. You can rotate the normal by using these two buttons here. The curves only have 1 degree of freedom when you rotate, because they rotate around the curve direction. They only need these two. But the point has 2 degrees of freedom. That's why we have this button too. So first you rotate it like this, and then you rotate it again around the Z axis, so the upwards axis, by using this one. So then you can control the exact normal. If you want to rotate it the other way, we don't have a button for it, but you can use Control D and Control A for the same as this button. The other way to make a plane is by drawing 2 points like this, and then you can choose the tilt of it this way, and then you can rotate it like this. Since ending a curve is done by double click, it means that you can make a single point curve by double clicking. And then you can do cut and double click, and you can do it quickly like that. The undo redo button stores the 3 last operations, so you can undo 3 times. 1, 2, and 3. When working with these curves and you get a result which doesn't make sense, it could be because one of the curves have sort of flipped normals. So let me demonstrate. Here the normals point up, but if you somehow end up making a curve a different place, which has the normals pointing down, so let's rotate it so it points down, like this, then you get a very strange surface. And that's why we have this rotate 180. But if you get this strange result, you might have to look at the normals of the curves by clicking on them and see, okay, these point up and these point down. Oh, that's why we have the problem. The software tries to avoid this problem by working such that when you start drawing, these first normals of the first 2 segments, they point upwards. And then after that, they continue to point in a coherent way. And what I mean by coherent way is that if you start like this, and then you go down and up like this, then they do point upwards here, and then they point downwards, and then they point upwards again, so that you get this shape, which you sort of should expect. The problem might arise if you draw the same curve, but you do it in multiple steps. Let's say you draw it like this, and the next step you start like this, so upside down here. Then you see that here the normals point upwards, and then it's wrong compared to this one. So here they're up, so they should point down here. So to fix that, and first of all you see that the shape is strange. And to fix that, you select this one and you can just press rotate 180 degrees. And then you have the way you want it. These surfaces are not just surfaces. They have an inside and an outside too. The normals point towards the outside or the air. And the other side is a solid. It's supposed to be interpreted as a solid. So it actually subdivides the cube into 2 parts, an air part and a solid part. And it's a solid part where the operation of cut or fold is applied. So if I now press cut, you see that it becomes solid. And then if I go back and reload the curves, and if I would invert the curves, so now it looks like the same surface because all the curves are going the other way. But you see one sign of that, which is this grid here. That grid communicates that the surface is that its solid part is up here and not down there. And actually, if you do press cut now, you get this result, which makes no sense geologically, though. But okay, let's go back. You have to be aware of what is the inside and what is the outside by looking at the normals. If I delete all the normals, you can also see that if I make a surface that goes up like that, this is the inside. And you can also see you get this grid here to communicate that this part of the top is on the inside. So if I press cut now, it will be filled like that. And if I would select it and rotate 180 degrees, I can also just do it like this. Then you see it will be the grid here is here because it tells us that this is on the inside. And then if I press cut now, you get this, which again is nothing geological meaningful, but just to be aware that we have an inside and an outside of the surfaces. Now we are ready to start creating a model using these surfaces. Initially the cube is empty. We select this tool here and we draw a curve and you have surface. When I press cut, the empty space in the interior will be filled. A new surface. When I press cut again, as I've told you that the interior is the other side of where the normals point. So the interior is that part here. And only the empty space of the interior will be filled. Whenever I do this, you get a new entry in this table here, which is the list of the layers. The layers are given a new color automatically and are given also a name automatically. And so on. You can change the color by pressing here. You can change the name by just writing something else. And you can also add a texture pattern by pressing this one. You can toggle on and off the visibility of the layers with this button here, hide. And you can select a layer by pressing the select button, and then you can see what layer is selected with these red lines. You can select multiple. There is a shortcut for the hide and select, which is if you choose this mode here, and when you are pointing on the layer at the side of the bounding box, one of the sides, not the top, but it has to be the side. If you press shift, then it selects the one you're pointing at. And if you press Control, then it turns it off and on again. Instead of cutting into air, like we did now, you can cut and split existing layers. Let's just delete all these layers. We can select all of them quickly by this button, and then we can just press delete. So let's make one thick layer and then cut into it. To cut into it, you just draw a new surface, and then you have to select the layer you want to cut into. In this case, there's only one possible option. Now when you press cut, what will happen is that this surface here, it has an exterior and an interior, and it is the interior part which will be given a new layer. Here you see it happened, and it also automatically selected the new layer. That's because then it's easy to just continue to draw like this and cut downwards to create layers downwards. You can cut several layers at the same time. So let's draw a shape like this. This is the interior part and this is the exterior part. If we now select these three here, not that one, and press cut, then it will become a new layer in this part. If I undo and load the same shape again, you can also do it like every second layer like this, but it might not make too much sense because you have one layer ID and the layer is not connected to itself. But you could easily just take this non-connecting layer and cut that in two parts by making a surface that is in between, and then I press cut, and then it will become two different parts. Notice here the effect of flipping the normals. So if I draw a similar shape and I select, just select all of them, and if I press cut now, then this here will be filled. But if I flip the normal, so that this is the interior and this is the exterior, then this area here will be filled instead, as you see. Also notice that this layer here is created and ends up at the bottom, although it's not at the bottom. So don't put too much emphasis on the ordering of the layers. When you do cut, a new layer might end up in a strange place. Okay, so let's undo, go back one step, and then I can show you how to cut inside an existing layer. If I select this one and I press cut, then you get a new layer inside the previous one. And here's an example of that it doesn't make sense where this new layer should be. It's wrong to have it above in the list and also below, because it's actually inside. But in this case, it's just below. Okay, let's undo that. And then I'll show you how to make a surface similar, but that covers several layers. So then we select the layers we want it to intersect. Let's select all the layers except the bottom one. And then when we press cut, you get this one. If you want to cut it but still keep the layer borders of the previous layers, then that is also possible. So let's do undo and get this curve back. The way to do that is by selecting one layer at a time. Let's see. This one, and then you do a cut. And then it made this. And then you reload your surface, and then you select the next one. Actually, that's not necessary to select, but this one, press cut again, unselect it, reload, and maybe it's easier to just select it by clicking here. Select that one, cut, unselect, reload the curve, and then we select this one, cut, unselect, and done. There we are. Now it is we are keeping the layer inside the cut. So that was the cut operation, and before showing you the fold operation, I will quickly show you the erode, merge and delete operations. Erode just simply takes all the material above the surface or in the empty space and removes it. So okay, let me move it a little bit down, and then we press erode, and then you see it is removed. Merge takes the layers you have selected and merges them into one layer. So we can take these two, or actually it's also this here, and if I press merge, it becomes one layer. Let's undo that. With merge, you can also merge layers that are not neighbors, which doesn't perhaps make too much sense, but like these two here, you can still do it. They get the same color. Let's undo that. And then you have delete. When you delete the layer, you just remove it, but the material that used to rest on the layer that is removed will fall down. So if I select this and delete it, then these parts will fall down. And you get a really strange shape. If you didn't really want this, you just wanted to make the layer below transparent, then you should instead just hide it. So I go back, undo, and then you just hide it like this. But this is not a geological operation, this is just a visualization operation. To demonstrate faulting, I will first make a new model which has a few simple layers like this, and then the fault surface cannot bend back on itself like it does here. A fault like this is okay, or even if it ends up into the top here, it's okay. And it can also end in the bottom and also the top. So here ends at the top and at the bottom. That's no problem also. Or it can go down and up again like this. So if we make, for instance, a fault like this, then when I press fault, you will see that only the layers that are intersected by the fault surface will be split. So you have these three layers here. This one is not affected. These three layers are layer 3, 4, and 5. So when I now press fault, you will see that layer 5 has been split in two. The other one is a little bit darker. Also for this layer, a little bit darker. And for this one, this is a little bit darker and it has been selected. These three new layers are being put on top of these original ones. The original ones are renamed such that this one is called layer 3 and it gets the postfix L for lower. And then on the right side, it is called layer 3U for upper. And the same for layer 4, lower and upper, and layer 5, lower and upper. So all these three here are the upper ones, and then it continues with the lower ones, like that. So the ordering is sort of logical. You can actually slide these top layers along the fault. You do that by selecting the layers you want to slide. Instead of selecting all of them, it is a shortcut that you only select one and the other ones above automatically are selected. To do the sliding, you go into geological modeling, natural processes, and then you choose which direction to slide. And you see when I move this, you can see this top thing rotate. So if we want to slide it to the right, we make sure that it points to the right. And then the sliding distance, you change, and when you change that, you see a preview of how the faulting will look like on the side, here and here. So this is a preview, and then when you press finalize, it will do it for the whole model. Then you need to move this back, and here you see the result. Let's try some other situations. Okay, we undo 2 times, and then I make a fault that goes like this. I press fault. It automatically selects the bottom one, so that if you want to do the sliding, it has selected the correct one. And then finalize and move that back, and then you get this result here. Let's go back and show you what happens if you make a fault like here. Then you have this. In this situation, you don't get a good result because the fault is modeled as going down and then going to the right. So when you move, you see this part goes to the right and this goes down, so you don't get what you want, but we'll try to fix that for a future version. The other way to use the faulting operation is when you want to recreate an illustration that has a fault. In that case, you don't want to perform sliding, you just want to draw it exactly as the illustration or the cross sections you have. How to do that is that let's just delete all of them. So one way to do that is that first you create the solid, then you fault it in the blocks. So that's one block and then a different block like this. And now you create the layers separately in each block. So you start with, for instance, this one, and you create layer by layer. So now using cut, and now you select this one, cut, cut, and finally you select that one. So then you have the resulting model, and in this case you used faulting just to subdivide the blocks. I forgot to say that when you make a fault, you can choose how deep it should go. So if I make this fault and I press F, it will apply on all layers. If you want it to only apply on the 3 upper layers or the 2 upper layers or just the top layer, then you just select these layers. So if I select these 2 and I fault, it will only happen on these 2. If I undo now, and if you select this and this, then it will go all the way from the deepest one and up, so it will include that one, like this. Now I will talk about where it is possible to draw these anchor curves. You can draw them on the sides of the bounding box, also on the top side you can draw. Let's delete them. You can also move the bounding box inwards and draw like this, and then draw like this. You can move the side of any side here, but be also aware that if you draw a curve here, then you might get a strange shape, because it tries to fit both that curve and that curve there. Let's delete that one. Also notice that when you move the bounding box, it cuts the surface. However, if you press Shift 5, then you see it with a grid and it sticks out. You can choose the mesh size of the holes in the grid in common settings, and this one. Shift F5 again to take it back. You can also draw these curves on positionable images and on the top terrain. First I will show you how to use the positionable images. Let's delete all the curves and create such an image. To do that, you go to Annotate, New Image Curve, and then you draw on the top bounding box a line. You start and you end, and you get this plane. You can draw on this plane, but to do that you need to turn off the bounding box. If the bounding box is on, it will draw on the bounding box. If you turn off the bounding box, you are now drawing on the plane. Both the curves drawn on the plane and on the bounding box, they remember which plane they were drawn on. So this curve here was drawn on this side here. So even if I move that bounding box side in, I can still move on the points of the curve and they will stay in the plane they were drawn in. Let's take this one, and as you see, they are staying in that plane. This is also true for this white plane, because even if I delete that image plane or I move it, still the points will first turn off the bounding box, and then when I select a point here and move it, it will move in that plane that it was originally drawn in, as you see here. There are different settings for the image plane, which you can access if you go to Annotations and you scroll down to the positionable image settings. You can, for instance, make it semi-transparent so you can see what's behind and still draw on it. But most importantly, you can have an image on that plane. To do that, you choose Choose Image. You navigate to a PNG file and then it shows up. So let's turn off the surface like this so we can see. So here you see this one, it can be drawn on, and you can take that image and you can rotate it 90 degrees or mirror it or change the height. By default, the height and width ratio is kept in the same way as the image is. You can also set the position of the image directly by pressing this button here. Then the coordinates are based on the axis coordinates, so we need to turn them on. Show axis. And you see it goes from 0 to 1000 meters in all 3 dimensions. So that means that when I press Set Image Position, x1, y1, z1 is the xyz coordinate of the upper left corner, and then x2, y2, z2 is the coordinate of the lower right corner. Fill it out, press OK, and the image will move and it will also stretch accordingly. Typically, you have several cross-sections that you want to draw the model according to. Let's add one more cross-section. New image, and also typically when you have several cross sections, you position them accurately using the set image position. Choose image, we choose this one. By default, it has smart transparency on, which means that areas which are of same color, homogeneous, become transparent. When you draw your model using images, it's important to be able to toggle on and off the model, the bounding box so you can draw on the image, and to toggle on and off the images. And the anchor surface too, and also to make the anchor surface grid view. The images are under the annotation menu, so that means also that you can turn off all images at the same time by pressing Hide Annotations. The last place where you can draw the anchor curves is on the terrain. So now it's possible to draw new anchor curves on that top surface here. You do that by pressing Draw on Layers. If you have several layers, then Draw on Layers will select the top one, and you will see these stripes here. They indicate that now when you draw an anchor curve, it is drawn on the terrain. You can either click draw or hold the button down and draw. The normals of the curve are taken from the normals from the terrain. Now if we add a small curve in the middle here and move that up, then you get a shape which is sort of in flush with the terrain, but we want this area here to be lower than the terrain, and you can do that by, for instance, okay, drawing around here and then moving that down. You can also rotate the normal and also here, move it down. Then you get something like this, and then when you press cut and then turn this off, you get a new shape that fits the terrain, which is flush with the normal and then changes. If we hide it, it looks like that. When you enable draw on layers, you have an offset slider which you can change. If you make that higher, you see that you will be drawing on something that's a little bit above the terrain. You can also make it lower, then you draw on something that is slightly, let's turn this off, lower than the terrain. And as long as you see this surface here, you can make the curve. Let's unhide these. And if we, as you know, if you press this, you get this surface here, and according to the offset, it's a little bit higher. But notice that this draw on surface can be for a different layer. If you don't select anything, it draws on top of the absolute top. But if you select this one, this layer here, then if you press draw on, then you will draw on top of that. But you cannot see it here, you need to turn off these two, and then you will see here, this is the one we're drawing on top of now. As you see, this can be complex, but it doesn't need to be. You can always just use the bounding box to draw, and you can either draw in on air like this, or if you want to cut existing layers, just always select all of them. And if you want to do faulting, just never select anything. And then you get quite far with that simple way of modeling.